Okay, these are the notes for section 8.2. I'm doing this on the Smart Slate, and this is my first try, so bear with me if this is a little bit slow. You should have got this chart in class, and the big deal is the range stuff here. What this basically means is if we're doing an inverse sine problem, our answer has to be between negative pi over 2 and positive pi over 2. If we think of this in the unit circle form, this means that, well, positive pi over 2 is going to the right pi over 2 right there. Negative pi over 2 is going down there, pi over 2. So basically what we're crossing out are quadrants 2 and quadrant 3. And the reason for this is that our answer to an inverse sine problem has to exist in these radian measures. If we're doing an inverse cosine problem, our answers have to exist between 0 and pi. Well, 0 is obviously right here in radians, pi is 180 degrees. So if we're doing an inverse cosine problem, we immediately cross out the bottom two quadrants. And last, if we're doing an inverse tangent problem, it basically follows the exact same rule as sine. If we're doing an inverse tangent problem, we are going from negative pi over 2, which is again back pi over 2, to positive pi over 2 up here. So again, we're crossing out the second and third quadrant. So when you see an inverse sine problem, immediately you cross out the left two. The same thing with an inverse tan. Immediately cross out the left two. If you see an inverse cosine problem, immediately cross out the bottom two. And then based on the problem, we'll cross out one more quadrant, and then we'll know exactly where to build our triangle. Okay, so here are the examples, A through J. Okay, example A. First thing, we see it's an inverse sine problem. So immediately, inverse sine problem, use your unit circle, cross out the left two quadrants. Go back to red so we can stay color-coded here. So we know we're going to, that's a terrible unit circle, but that's okay. We're going to cross out the left two. Now, since sine is equal to a positive number, and we think all students take calculus, we know that sine is positive up here, but it's negative down here. Since I want positive, I'm going to cross out the fourth quadrant. And now I just got to think, okay, what special triangle has the sine, meaning the opposite, equal to 1/2? Well, that's a 30-degree reference in the first quadrant. So that'd be a 30-degree triangle. And then I say, okay, well, what is that measure right there? Well, that is pi, try that again, pi over 6. And there we go, there's our answer. And I just want to show you real quick, this is inverse sine of 1/2. If I do this in my calculator, oh, it doesn't like this thing, hold on. Okay. If I do inverse sine, second sine, 0.5, 1/2, I get that number, and that actually is pi over 6. Same thing. So I see that the inverse sine of 0.5 is what we found, pi over 6. Okay, on example B, again, I'm doing an inverse sine problem. So immediately, inverse sine means cut out the left two quadrants. So immediately cut out the left two quadrants. This time, sine is equal to a negative. So I have to cross out the first quadrant because it's going to be negative. I know that sine is negative down here. Then I go, okay, what triangle has root 2 over 2 for the opposite? Well, that's a 45 reference. Now, what we used to call this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So it'd be 7 pi over 4 is that radian measure. But again, inverse sine, the answer has to be between these two numbers. 7 pi over 4 is too big. Instead, we call it negative pi over 4, which again, the negative just represents going the other way on the circle. Instead of going counterclockwise like we usually do, we're going counterclockwise to there. On example C, it's an inverse cosine problem. So again, inverse cosine, I looked at my chart, and it has to be between 0 and pi. So immediately I cross out the bottom two quadrants. And I'll go blue here. So immediately cross out the bottom two quadrants. Now this one's actually a little easier than the other ones. When does cosine equal 0 between here and here, between 0 and pi rotation? Well, the only place it actually happens is on the axis up here, because this is the point 0, 1. And remember, it goes cos, sine. And so the cosine is 0. And then I just have to say, okay, what is that radian measure to there? Well, that's pi over 2. That's a terrible pi on that one, but you get the idea. And again, I can check these things on the calculator. So if I do the inverse cosine of 0, inverse cosine of 0, it gives me 1.57, blah, blah, blah. And that is equivalent to pi over 2. And there we go. So again, obviously on the test during this stuff, you wouldn't have a calculator, but we're verifying that, yeah, what we're doing is the correct way. On the next problem, I'm doing an inverse tangent problem. Again, inverse tan is just like inverse sine. I cross out the left two. My answer has to lie in these numbers. So on this one, on my unit circle, and that was a little better one, immediately cross out the left two. Since it's a negative number, tangent's positive here, so I cross that out because I want negative. This one's a little trickier because I got to think what triangle has opposite over adjacent equal to root 3 over 3. That's a little trickier. We're not quite as used to that one. Well, it turns out that it's a 30-degree reference because the opposite of a 30 degree is 1/2. Go away. Okay. Un momento. Have a little technical difficulties here. Hold on. All right, I think we're back. Okay, it's a 30-degree reference because the opposite of a 30 degree is 1/2. The adjacent to a 30 degree is root 3 over 2. So if I multiply by the reciprocal, 2's cancel out here. I'm left with 1 over root 3, which when you do the whole rationalizing fun stuff, multiply top and bottom by root 3. There we go. So all that was just to tell me that the angle that gets me negative root 3 over 3 is a 30-degree reference down here in the fourth quadrant. And again, I used to call that 11 pi over 6. But now since our answer has to be between negative pi over 2 and pi over 2, I can't call it 11 pi over 6 on this. I have to call it negative pi over 6. So there's my answer to this problem, negative pi over 6. So hopefully you're starting to get the idea here. We basically have to cut out two quadrants. Then we look to see if it's positive or negative. If it's based on that, we will cut out one of the other quadrants. Then we just need to draw a triangle. On the next one, inverse sine of negative 1. So again, inverse sine problem, we cross out the left two. So gone, gone. It's a negative answer here, so I'm certain that I'm not up here. And again, this is actually one of the easier ones. When does the sine equal negative 1? Well, that's actually on the axis down here. This dot is the point 0, negative 1. And then again, we used to call that 3 pi over 2, but now instead we're calling it negative pi over 2. And there's the answer. Again, you may think, oh, well, that's not in between my numbers. Well, I have brackets on these. That means that negative pi over 2 does count. It's in the range. So negative pi over 2 is allowed. And letter F, I'm doing inverse cosine. So again, cosine means cut out the bottom two. Since it's negative, cross out quadrant 1 because I need negative, and then I go, okay, what triangle has an adjacent, because it's a cosine problem, of root 3 over 2? Well, the one that has the adjacent of root 3 over 2 is terribly drawn here, but a 30-degree reference triangle. That's 30. And I go, okay, well, what is that angle? That's 1, 6, 2, 6, 3, 6, 4, 6, 5 pi over 6. And again, 5 pi over 6 is between 0 and pi, so it does work. It is in that range. Okay, these ones get a little bit trickier, but not by a whole lot. The first thing I'm doing is, I'll use a different color because this doesn't go with any of it right now. I'm just doing the sine of pi over 6. This we've done since November of last semester. I just go, okay, where's pi over 6? Well, that's a 30-degree reference. What is the sine of pi over 6? Meaning, if that's a 30-degree, what's the opposite since it's sine? Well, it's 1/2. So this part just becomes the number 1/2. So now I'm really just doing the inverse cosine of 1/2. Now again, I go, oh, I'm doing an inverse cosine problem. Inverse cosine means cut out the bottom two. It's a positive number, so cut this one out because cosine's negative there. And now I have to go, okay, what triangle has an adjacent, because it's a cosine problem, of 1/2? That would be a 60-degree reference, has the adjacent of 1/2, so that's a 60-degree angle in there. And then I go, okay, what is that angle? Because again, inverse trig gets you angles. That is pi over 3. And I'm done. And again, you can check these things in your calculator, so I'll do this one again. The inverse cosine of the sine of pi over 6. Okay, so... Come on, friend. There we go. The inverse cosine of the sine of pi over 6. Close the parentheses off, and it gives me that number. Okay. Well, let's check that. I found my answer to be pi over 3. So pi over 3. Here's hoping. And voila, same answer. So I did it right. A few more here to go. Same concept on this one. This is what we did way back in November. We've been doing since. So I just got to go, okay, where's 7 pi over 6? That would be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 7 pi over 6. So it's a 30-degree reference down here. The adjacent, since it's a cosine problem, the adjacent is the root 3 over 2. You got to be careful here because all students take calculus. Cosine is negative down here because only tangent is positive. So the answer to this is actually negative root 3 over 2. So again, what I'm actually doing is the problem inverse sine of negative root 3 over 2. Now I go, okay, I'm doing an inverse sine problem. Inverse sine problems immediately mean cross out the left 2. Cross out the left 2. It's negative, so cross out the first one because I need sine to be negative. Then I go, okay, what triangle has an opposite of root 3 over 2? Well, that's a 60-degree reference. So that's 60. And then I go, okay, what is that angle? But remember, I'm considering it in negative rotation, and that is negative pi over 3. And again, I'm going to show this one on the calculator because this one got a negative answer. We haven't had much yet. If I go, let's see which problem is this. Okay, inverse sine of the cosine of 7 pi over 6. How to get negative, when we should see that that was what we had before. And if we did negative pi over 3, we would get negative 1.047. So it is the same answer. So we did do it right. Okay, a couple more problems here. The cosine of pi. Again, this is what we've been doing for months. It's a terrible unit circle, but anyway, pi is 180 degrees. So the cosine here, well, the point is negative 1 comma 0. And so I go, okay, the cosine is the negative 1. So this answer is just negative 1. So now I'm really just doing the inverse tan of negative 1. Okay, since I'm doing an inverse tan problem, I'll get my green. Inverse tan problems, you cut out the left 2 quadrants. So if I cross out my left 2, and then it's negative, so I cross out the first one because I need negative, and then I go, okay, what triangle has opposite over adjacent equal to 1? Well, that's a 45 reference because the legs are the same. So my angle is 45 degrees. And so that rotation is negative pi over 4. Again, we used to call it positive 7 pi over 4, but since we have to have our answer lie within this range, I'm just calling it negative pi over 4 instead. Still the same spot on the unit circle, it's just the name of the angle is a little different. Okay, last one on these notes was a little weird one. First thing I'm doing is an inverse sine. So don't worry that this is something bizarre that we haven't seen much of. Inverse sine problem, it means immediately cut out the left 2. It's positive, so cross out the bottom. Now, I don't know what angle actually gives me 5 over 13, but it actually doesn't matter. I just know that there's some triangle in the first quadrant that has opposite over hypotenuse, because SOHCA, TOA, S-O-H, opposite over hypotenuse is 5 over 13. Now, I don't care what this angle is. I can call it theta, I can call it happy face, I can call it whatever the heck I want. I don't care what it is, because all I'm going to do is take that angle, theta, and I'm going to do the tangent of that angle. Well, I already know where I am on the unit circle. Well, this isn't actually a unit circle, but I know where I am. I'm at this 5 over 13 spot. If you do Pythagorean theorem, you get that this side is 12. So the tangent of theta, there's theta right there. Tangent means opposite over adjacent. So the tangent is simply 5 over 12. Again, we didn't even care about what angle we actually got on this one, because all we're going to do is take whatever that angle was and do another trig function on it. And again, this one you can actually check on your calculator as well, even though it's not a special one. So it's the tan of the inverse sine of 5 over 13. So tan of the inverse sine of 5 over 13. And it gives me 0.416 repeating. And I thought the answer was 5 over 12. Well, 5 over 12, there we go, is, go figure, the exact same thing. So it did work out. So again, in recap, if you're doing an inverse trig function, immediately cross out 2 of the 4 quadrants. Then, if your problem has a positive number, you'll cross out one of the remaining 2 quadrants, like here I crossed out this one. If it has a negative number, you'll cross out a different quadrant, like right here I crossed out this one. And then just draw your triangle and figure out what the angle is. And remember that our answers have to be in these ranges based on which problem I'm talking about. So I can't just pick any old angle I want. It has to be between here, or here, or here, depending on if you're doing sin, cos, or tan. Hopefully this helps a little bit, and we'll talk a little bit more about it Monday.